This is the third video on vectors, which is from class 12 maths chapter 10, and in this video I am going to give the complete solution of exercise 10.3. Starting with the first question, angle between two vectors we have to find, and which a dot b is given, magnitude of a, magnitude of b are given. So we know if two vectors a and b making an angle theta in between, then angle is given by cos theta is equal to a dot b by magnitude of vector a into magnitude of vector b. And here all the data given, a dot b is given square root of 6, magnitude of a is given root over 3 into magnitude of b also is given root over 2, and we can simplify. Cos theta is equal to root 6, we can write root 3 into root 2, and root 3 same. 2 can be written as root 2 into root 2. It is like this, x can be written as root x into root x. So root 2 writing root 2 can writing root 2 into root 2, so that we can cancel. And finally remaining cos theta is equal to 1 by square root of 2. So it can be written as 1 by root 2 is known value, standard value it is cos of 1 pi by 4. Cos 45 degree is 1 by root 2. Now cos is getting cancelled on both sides, and hence the angle is pi by 4. So we got the angle between the two vectors. Question number 2, it is given vector a is given, vector b is given, and we are asked to find the angle between. So angle between the vectors is given by the formula cos theta is equal to a dot b by magnitude of b, which we know. So at first we must find out the dot product, magnitude of a vector a and magnitude of vector b. So these are the two vectors given. Then a dot b is equal to first vector dot with second vector, and dot product we know it is found like this: first number into first number, coefficient of I into coefficient of j, that is 1 into coefficient of j is 3, plus coefficient of j minus 2 into coefficient of j again minus 2, plus coefficient of k 3 into coefficient of k 1. So this is how we find the dot product. So it is 3 plus 4 plus 3, so it is 10. Then magnitude of vector a, magnitude we know, vector a magnitude is coefficient of I square, coefficient of j square, again coefficient of k square, so it will be root over 14. 9 plus 4 13 plus 1 14. Again magnitude of b is same way, coefficient of under square root, coefficient of I square, coefficient of j square, coefficient of k, that is 1 square, it will be again square root of 14. And then we will put here in the formula dot product, we got 10 by square root of 14 into again square root of 14, and square root of 14 into square root of 14, it is equal to 14 only. Now we can cancel, it is 5 by 7. So cos theta equal to, we are getting 5 by 7, which is not a standard value in the trigonometric table, so we can make it theta is equal to cos inverse of 5 by 7. So this is the angle between the two vectors. Question number 3, two vectors are given. A is, first one I'll take it as A, second one will mark it as B, and we are asked to find the projection of vector A on B, and this is the formula for projection of A on B, which we have discussed. Projection concept, it is given in the first video. Projection of A on B is given by this formula. So in this formula the terms we need A dot B and magnitude of B. So at first I am finding A dot B, vector A I minus j dot vector B is I plus j. K is not there, you can write 0k, no problem, 0k we can write. Now dot product is found like this: coefficient of I, that is 1 into coefficient of I again 1, plus coefficient of j minus 1 into coefficient of j is 1, so it is 1 minus 1, it is 0. Then we need magnitude of B. So magnitude of B we can find out, it is sum of square of, this is the vector B, here 1 1, so coefficient of I square, coefficient of j square, coefficient of k square, so you are getting square root of 2. And this is the formula for projection of A on B. Projection of A on B is the length of shadow of A on B, which we have discussed in the first video, and we are getting now A dot B is 0 by magnitude of B is square root of 2. 0 divided by anything is 0. So we got the projection of vector A on B. Question number 4 again exactly same. One vector given, two vectors are given. First one will mark it A, second one will mark it as B, and we are asked to find the projection of A on B. And projection concept is like this: if we from the end point of A, if you draw perpendicular to the other vector, then distance between these two perpendicular is the projection. This distance between the two perpendiculars is the projection of A on B, which is given by this formula. So in this formula we can clearly see we have to find out the dot product and we have to find the magnitude of B. So at first I'll find the dot product. A dot B. A dot with B, and dot product is found like this: coefficient of I, that is 1, into coefficient of I 1, plus coefficient of J into coefficient of J, coefficient of K into coefficient of K. So it is 7 minus 3 plus 56. So 56, 7 minus 3 is 4, 56, so it is 60. Then we will find magnitude of B. Magnitude of B is, this is the vector B, magnitude is coefficient of I, that is 7 square, coefficient of J minus 1 square, coefficient of K, that is 8 square. So it will be 49 plus 1 plus 64. So it is 114. And this is the formula for projection. We are just putting the values. A dot B we got 60 and magnitude of B we got square root of 114. So this is the projection of vector A on the vector B. And it is the complete solution for this question. Question number 5. Three vectors are given. We will take it A, B and C. And we are asked to show that the vectors are mutually perpendicular to each other. We have to show their unit vectors and mutually perpendicular to each other. Unit vector means magnitude should be 1 and mutually perpendicular means dot product should be 0. Scalar product or dot product between any two vectors must be 0. So first vector A, I can simplify it. We can make it, this 1 by 7 can multiply. It is 2 by 7 I, 3 by 7 J, 6 by 7 K. Same way this one I can write it 3 by 7 I. We are just simplifying 2 by 7 K. Here also I can write it 6 by 7 I, 2 by 7 J minus 3 by 7 K. We have two parts in this question. First step, we are asked to show that the vectors are unit vectors. Unit vector means each vector is of magnitude equal to 1. So first I'll find magnitude of A. Magnitude of A, if we find it is 2 by 7 square, coefficient of I square plus coefficient of J square plus coefficient of K again square. So if we simplify and finally we will get, it will be 49 by 49 which is equal to square root of 1 which is equal to 1. 1 means, magnitude 1 means A is a unit vector. Same way we will find magnitude of B and we will again get it equal to 1. Also magnitude of C, same way we will again get the value equal to 1. And we will say since magnitude of A equal to magnitude of B is same as magnitude of C equal to 1. Therefore, the vectors A, B and C are unit vectors. A vector of magnitude 1 is called a unit vector. So the first part solution is done. The first part is to prove that the vectors are unit vectors. So first part is done. Now the second part, we are asked to show that they are mutually perpendicular. Perpendicular vectors means their dot product must be 0. Mutually means A dot B must be 0, B dot C also must be 0, A dot C also must be 0. So second part I'll solve. First I'll find A dot B. So A dot B is found like this: coefficient of I into coefficient of I, 2 by 7 into coefficient of I is 3 by 7 plus coefficient of J 3 by 7 into coefficient of J minus 6 by 7 plus coefficient of K into coefficient of K. Now if we simplify, we will get it equal to 0 and we will say therefore A perpendicular B. Since their dot product 0, vectors are perpendicular. A dot B 0. Same way we can show B dot C, we can find out and we can show it is also 0, and A dot C also we can find out same here, we will show 0, and then we will say therefore hence ABC are also mutually perpendicular. Therefore A, B and C vectors are also mutually perpendicular to each other. Mutually perpendicular. So this is the complete solution for this question. Question number 6, it is given like this: a plus b dot with a minus b is 8, and we are asked to find the magnitude of a and magnitude of b, and one condition is given: a magnitude is 8 times magnitude b magnitude. So at first I'll apply here dot product. It is just like ordinary multiplication, but in between there is dot. So it will be a with a dot a, then a with b minus a dot b plus b dot a, plus into minus is minus b dot b. Right hand side is 8. Now we have to remember these nodes: a dot a is equal to magnitude a square, and another formula we know a dot b is same as b dot a. These two formula we have to know. We are going to apply here. So a dot a, I can write magnitude a square. A dot b and b dot a same, they are getting cancelled. So this same formula a dot a magnitude a square can be applied for vector b also. So it will be b magnitude square. Right hand side is 8. Now I can use this equation, this condition given. In place of a magnitude I can write 8 times b magnitude square is there, minus b magnitude square. Right hand side is 8. 8 square is 64 into b magnitude square minus b magnitude square is equal to 8. 64 minus 1, it is 63 times b magnitude square is equal to 8. And finally b magnitude square is 8 by 63, implies b magnitude, it should be plus minus square root of 8 by 63, and negative not possible because magnitude, so it must be only positive, so we cannot take negative. So we got the b magnitude. Question asked to find a magnitude and b magnitude, so we already got the b magnitude. Now from equation 1 we can find a magnitude. A magnitude is 8 times b magnitude, so 8 times b magnitude is 8 by root over 63, and it can be simplified further. So further means this 8 can be written as 2 root 2 by root 63. Here also the same thing can be applied. So this is the complete solution for this question. Next question is exactly same. 2 terms given, in between dot product is given. So 2 terms in between dot. So just like ordinary multiplication, it is 3 to the 6 a dot a. Then first with second, it will be plus 3 7 ja 21 a dot b, minus 5 and 2 5 to the 10 b dot a, minus plus minus 7 5 ja 35 b dot b. Now we have to know this condition. A dot a can be written as magnitude a square, which we have learned in the first video, and a dot b is same as b dot a. So this can be applied. So it is 6 a dot a magnitude a square, then 21 a dot b minus 10, so it will become 11 a dot b. 21 minus 10 is 11, minus 35 b dot b can be written as magnitude b square. So this will remain as it is. This is the answer because no other below no the data is given. Question number 8, find magnitude of two vectors having same magnitude. So magnitude a magnitude b equal to, we can take say k, and angle between them is 60. Now definition of dot product, this is the definition of dot product: magnitude a magnitude b. A dot b is equal to magnitude a magnitude b into cos theta. Theta is 60 degree here. Now dot product is given, scalar product or dot product, the value is given 1 by 2. Magnitude a is k, magnitude b also k, and cos 60 value we know it is 1 by 2. Then 1 by 2 is equal to k square into 1 by 2. We are getting k square is equal to 1, implies k is equal to plus minus root over 1 actually, but magnitude cannot be negative. So k will be value only 1. Therefore magnitude a is same as magnitude b is equal to 1. The question is to find the magnitude of the two vectors, and hence the magnitude finally we got equal to 1. Question number 9. This is the term given x minus a dot x plus b is 12. This is given, and it is mentioned that unit vector a is a unit vector, so magnitude of a must be equal to 1. It is mentioned unit vector, and then we have to know this a dot b. A dot a is magnitude a square, and a dot b is same as b dot a. These two results we have to know. And since a is a unit vector, you will write here, since a is a unit vector, so magnitude of a is equal to 1. And you are asked to find what will be the magnitude of x. So we'll proceed with this. Given x dot x, just like algebraic multiplication, but in between dot is there. X, then x with a, it is positive. Then a with x negative. And a with a, it is a dot a. Right hand side is 12. Now we have learned here a dot b equal to b dot a, so x a and ax will get cancelled, they are equal. X dot x is magnitude of x square. It is by this first condition, this one, a dot a magnitude of a square, and here the same again, a dot a is magnitude a square. Right hand side answer is 12. Now magnitude of a is given here 1, so magnitude of x square minus 1 is equal to 12. Implies magnitude of x square is equal to minus 12 minus 1, taking to the right side will be plus 1, so it is becoming 13. And magnitude of x will be plus minus square root over 13, but magnitude cannot be negative, so magnitude will be only positive, and this is the value of the magnitude of x. The question is to find magnitude of x, so we finally got. Question number 9. 3 vectors are given a, b and c, and it is said that a plus lambda b is perpendicular to vector c. So a plus lambda b is perpendicular to c, then their dot product must be equal to 0. A plus lambda b dot c must be equal to 0 because these two vectors are perpendicular. We have learned in the first video, if two vectors are perpendicular, then their dot product is 0. So at first we have to find out this term, that means a plus lambda b. So I am finding here a plus lambda b. It will remain same, 2i, 2j, 3k, and the second vector is multiplying by lambda, so it will be lambda I plus 2 lambda j, lambda multiplied, so lambda k. Now I'll take I together. I'm simplifying, 2i minus lambda I together, then 2j, j together, plus 2 lambda j, k together, 3k and lambda k together. Then I'll take lambda I common, so 2 minus lambda into I, and 2 plus 2 lambda into j, and 3 plus lambda into k. So I got the vector a plus lambda b. Now a plus lambda b perpendicular to c, so their dot product is 0, and we can now put the values. A plus lambda b I have got here. This is the vector a plus lambda b, 2 minus lambda into I, 2 plus 2 lambda into j, then 3 plus lambda into k. And this vector dot with vector c is given here. It is 3i plus j plus 0k, 3i plus j plus 0k, and right hand side is 0. Now dot product, how do we find? Dot product is found coefficient of I, 2 minus lambda, into coefficient of I plus coefficient of j into coefficient of j is 1, coefficient of k into coefficient of k is 0 equal to 0. Now we can simplify and we can get the value of lambda. The question is to find lambda, so we can find it. Next question number 11. These are the two vectors given. These two vectors we are asked to show that they are perpendicular. These two vectors are perpendicular, and it will be, to make it easier, let magnitude of a will represent by L, magnitude of b let it be m, so that it will be easier. And we are asked to show that this vector and this vector perpendicular, that means we have to show that their dot product is 0. We have learned before, if two vectors perpendicular, then their dot product must be 0. So this vector and this vector perpendicular, so their dot product must be 0. We are to prove it. Now magnitude of a I am writing here L into vector b plus and m into vector a, dot a is L, magnitude a is L, and magnitude b I am writing m into. Now dot product we have to find out. L into L, it is L square B dot B. B vector dot B. Dot product is in between vectors. L and M are scalars here. Now this with second, it will be minus L into M B dot A, and second into first again plus M into L A dot B. You remember, as I said, dot will be in between vectors and L and M are constant. Why dot? Because in between we have dot here. Now second with second again, plus, no, it will be minus. Plus into minus is minus. M into M is M square A dot A. Now we have learned A dot A is magnitude of A square. So it is L square into B dot B is magnitude B square minus L M B dot A dot B same, so B A I can write A B plus M L or L M same thing, A dot B minus M square. A dot A is magnitude A square, which we have written here, which we have discussed here. Now this term getting cancelled because equal terms with plus and minus getting cancelled. Now it is L square, magnitude B is M square minus the last term is M square into magnitude A is L square. Now you see exactly same minus same term, which is equal to 0. And since these two vectors dot product we are finding, and finally we are getting 0, and hence the two vectors are perpendicular to each other. We can write therefore the given vectors are perpendicular to each other. Next question number 12. A dot A is given 0 and also A dot B is given 0. Now what can you conclude about B? A dot A we have learned A dot A is magnitude A square equal to 0. That means magnitude A is equal to 0. Now A dot B definition we have learned, definition of dot product, it is magnitude A into magnitude B into cos theta. Right hand side is 0. Now magnitude A is already 0 here we have got. So 0 into magnitude B cos theta equal to 0. That means 0 into anything is 0. That means magnitude B can be anything, and hence the vector B can be any vector. Vector B can be any vector. B is any vector. Vector B can be any. It is given A plus B plus C in this question number 13. A plus B plus C is a 0 vector, and also it is said that ABC are unit vectors. So since ABC are unit vectors, therefore magnitude of A, magnitude of B, magnitude of C equal to 1. Unit vectors magnitude 1, I can mark it equation 1, I am going to use it again. Then A plus B plus C equal to 0. I will take first step, I will take magnitude on both sides. Taking magnitude on both sides. So magnitude of left hand side is equal to magnitude of right hand side. So magnitude of 0 is 0. Now I will again square both sides, squaring both sides. So left hand side square equal to 0, square is 0. Now in left hand side I will use this formula. We have learned A dot A is equal to magnitude A square. I can reverse it. I can write magnitude A square is equal to A dot A. Now this one I will apply here in left hand side. The whole thing I will take it A. A magnitude square will be A dot A. So it will become A plus B plus C dot A plus B plus C. I have taken the whole vector is A. So A magnitude square is A dot A. This is the formula condition. So it is correct. Now I will find out dot product. Right hand side is 0. I will find the dot product of the vectors. A dot A, then A with B, A with C. Dot is there in between. Same A with B, dot A, B with next B dot B, B with C. That means B dot C. Then again with C, CA, C with B, C with C, right hand side 0. Now just now we have discussed these conditions we are going to use. A dot A is magnitude A square, and also we know A dot B is same as B dot A. So these are the two conditions we are going to use. So A dot A, I have magnitude A square. Same way I have here B dot B, so I can write it magnitude B square. Then I have here C dot C, which I can write magnitude C square. So this term I have written, this term I have written, this term I have written. Now what is remaining? You see AB and another BA same. AB and BA same, so I can write twice AB. Similarly, BC, CB twice, I can write twice BC, dot is there in between. AC and AC is twice again, I can write twice A dot C. Right hand side is 0, left hand side all the terms I have written. Now this magnitudes ABC I have here, magnitude ABC 1, because there are unit vectors mentioned, so each vector is of magnitude 1. So I can write here 1 square, for this again 1, for this again 1 square, and then in these three terms I can take 2 common, remaining AB, BC, then AC right hand side 0. 1 plus 1 plus 1 is 3, so twice A dot B, B dot C, then A dot C, right hand side is minus 3. This plus 3 taking to the right side, it is minus 3 now. Then A dot B, B dot C, A dot C, it is minus 3 divided by 2. This 2 is cross multiplied there, and this is the answer. The question is asked to find the value of this term A dot B, A dot B dot C, C dot A, and we got finally A dot B, B dot C, C dot A dot C same. So this is the complete solution for this question. Question number 14. If A is 0, B is 0 vector, then their dot product is 0, but the converse is need not be true. So we have to show with an example. That means we have to show with an example that two non-zero vectors dot product can be 0. We have to show. According to the question, we have to show two non-zero vectors dot product can be 0. Dot product 0, but vectors may not be 0. So I am taking an example. You see, one I plus j plus 2k and another is minus k. Then if I find a dot product, first vector dot second vector, dot product or scalar product. Dot product, we know coefficient of I 1 into coefficient of I is 1 plus coefficient of j 1, coefficient of j is 1 plus coefficient of k into coefficient of k. So 1 plus 1 minus 2, it is 2 minus 2, and we are getting 0. So what we have got, you see, dot product is 0, but the vectors are not 0, and this is the proof for this question. Question number 15. ABC are the vertices of a triangle. 3 points given A, B and C. So I will first mark it. This point is A, it is 1, 2, 3. This point I will mark it B minus 1, 0, 0, and this point is C, 0, 1, 2. And according to this angle you have to find out, see the question, angle ABC. That means this is the angle we have to find. We will mark it theta. Now we can clearly see in the diagram angle theta. Now it is made by vector BA and it is vector B2C. So at first we will find out vector BA. We know it is found by second minus first, position vector of second and minus first. So in this order we are writing A is second. So A position vector will be 1i plus 2j plus 3k minus first. First is A. Sorry, first is B. It is here. Minus 1i 0j 0k. So it is minus 2i plus 2j plus 3k. And I can mark this vector A now. The other vector I need BC. The angle theta is between BA and BC. So first one I am representing by A. Second one I will represent by B. So B is which vector? It is B2C. Again the same concept. Second minus first. So BC, C is second, B is first. C, 0i, 1j, 2k. This is the vector 0i, 1j, 2k. Minus first is B. B here, B is minus 1i, 0j, 0k. So it is 0 minus, so it will be 1i, 1j 2k. Now we are asked to find this angle between vector a and b. We got the vectors a and b, and which we have just learned in this video. We will find a dot b dot product. We know how to find magnitude a. We know how to find magnitude b also we can find. And angle is given by cos theta. Angle BAC or ABC, it is written here. It is the theta angle, and cos theta is given by a dot b by magnitude of a, magnitude of b. We can put the values and we can simplify, which we have done at the beginning. Now question number 16, 3 points are given and you are asked to show that the points are collinear. So using vectors 3 points, you can find like this: a to b, a to c. This one you find a b, and this one you find out a c. And collinear vectors will be a is equal to lambda into b. So first we will find out a b. I'll write the coordinates given 1 2 7. B is 2 6 3, C is given 3 10 minus 1. Now AB will be second minus first. I'll do shortcut. 2 minus 1 is 1i, then 6 minus 2 is 4j, 3 minus 7 is minus 4k. Then same way I'll find out again AC. AC is again second minus first. 3 minus 1 is 2i, 10 minus 2 is 8j, minus 1 minus 8k. So here you see now AC vector is 2i, 8j minus 8k. I can take here 2 common. So 2 common, it will be I plus 8, 2 4j 8 minus 4k, which is, you see, 2 into AC is 2 into AB. This is now vector, this is vector AB now. That means we are getting AC is twice AB, and we can say therefore points are collinear. Collinear condition, you see, collinear, two vectors are collinear if they satisfy this condition: A is equal to lambda b. So here we are getting AC is equal to 2 into AB. That means AC is some lambda into AB, and we can say therefore the points are collinear because they are satisfying this collinear condition. We can say therefore the given points are collinear. So this is the complete solution. Question number 17. Question number 17. 3 vectors are given, 3 points. The first point A, second point is B, third point C. These 3 vectors are the position of 3 points, which we call position vectors, and which makes the triangle. And we are asked to show that the triangle is a right angle triangle. Right angle triangle means satisfying Pythagoras theorem. So at first we are finding AB vector, AB representing one side, AB. It is found by second minus first. I have got it, AB vector, and its magnitude also I have found. Then another is BC, B to C, again second minus first we have found here. We found its magnitude also. Then another A to C, again second minus first we have found the magnitude. Now this is one magnitude, another. So I can show now, see, BC magnitude square plus AC magnitude square is equal to BC magnitude we got root over 6 square, AC magnitude we got root over 35 square. So it is 6 square and root got cancelled, 6, and here also square and root got cancelled, again 35, which is 41, and it can be written as root over 41 square, so that in place of this we can use AB magnitude, because AB magnitude is root over 41. So this can be written as AB magnitude square. That means it is satisfying Pythagoras theorem. This is Pythagoras theorem. BC square plus AC square is equal to AB square, and we can say therefore the triangle is a right angle triangle, and is the complete solution. Now question number 18, the last question of this exercise. It is given A is a non-zero vector of magnitude A and lambda is a non-zero scalar. A is that means it is given magnitude of A is equal to A. Magnitude of A vector is A. Lambda is a non-zero scalar. Now also it is said that lambda A is a unit vector, so its magnitude must be equal to 1. And then you see it will be magnitude of lambda into magnitude of A equal to 1, and magnitude of lambda, magnitude of A is given, A magnitude of A vector is given A is equal to 1. So lambda magnitude will be 1 by A, or we can say A is equal to 1 by lambda magnitude. So A equal to 1 by lambda magnitude is option D is the correct solution. This is the end of this video, and in this video I have given the complete solution of exercise 10.3.